Question number 21 says a water wave passes into a region where the wave travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? So, if it's traveling slowly, think in terms of the formula. Speed of a wave equals to frequency multiplied by wavelength. Frequency cannot change because it depends on the source. Until something at the source changes, the frequency won't change along the way. So F, or frequency, that would be your constant here. That means if the speed is changing, the only thing that can explain that based on the formula is the wavelength. So speed is going down, wavelength must be going down. Simple as that. You have the answer. It's going to be option C. Questions like these demand that you have a knowledge of the underlying formula. In fact, the higher up you go in physics, the more this skill will get tested. So the earlier you develop it, the easier future physics is going to be for you, because it is going to be an idea that is going to be tested very often. If the answer doesn't lie in some principle like Newton's laws or something qualitative like that, then the answer must lie in a formula. You read the situation, you think about the appropriate formula, and then by inspecting the formula, you can decode the answer. Light traveling at a speed of 3 into 10 to the power 8 meter per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. So what do you see? Typical glass block diagram drawn as a rectangle. There is a dotted line known as the normal. There is an angle of incidence 55 degrees. There is an angle of refraction 33 degrees. I would take this opportunity to remind that if they were to give you the angle between the ray and the glass block or the surface, don't take that as the angle of incidence. That is a trick. You have to remember that the angle of incidence is always between the normal and the ray, right over here. So if we have the angle between the ray and the surface, we subtract that from 90 degrees to get the angle of incidence. So if this is 55, the angle of the ray and the surface should have been 45 degrees, right? What is the speed of light inside the glass? So we have studied about light, that its speed in vacuum is 3 into 10 to the power 8 meter per second, highest known speed. So if the speed of light in vacuum is the highest speed in our universe, visible universe, then it can't be higher than this, right? It can be something lower than this though. But the answer doesn't depend on that alone, since we have a bunch of numbers which are lower than the given value. You can delete option C and D. They are higher than the given value, 3 into 10 to the power 8. Only option A and B, one of them has to be right. Now your goal is to figure out which one is going to be the speed of light inside the glass block. So the data that we have allows us to calculate the refractive index. Let's do that because there's another formula that relates the refractive index to the speed of light. Sin I over sin R equals N. So sin 55 divided by sin 33 equals N. Let's find out N on the calculator. $1.5. And then we have a formula with which basically we can find out the refractive index in terms of the speed of light in vacuum and speed of light in a given medium. x is our unknown, the speed of light in the medium. We know the refractive index, 1.5. So we'll just solve this formula here. Two into 10 to the power 8 when you solve this, which is option B. There you go. Just a matter of looking at data, thinking of appropriate formulas, and it gets you towards the relevant end. When you look at the data, 55 degree, 33 degree, you're like, okay, I cannot connect the angles to the speed of light in any way to get the job done. So then what is the other route? You immediately recall that, yeah, I have a formula for refractive index, sin I over sin R, and then I have another formula of refractive index based on the speed of light in vacuum. So sin I over sin R gives you the refractive index 1.5. You then relate that to the speed of light in vacuum and speed of light in medium. So speed of light in vacuum divided by the speed of light in medium. You get 2 into 10 to the power 8. The answer option B.